Hi, today I will show you how you can turn your Raspberry Pi 3 into a Bluetooth audio receiver. And that will enable you to stream music from your phone or tablet to your Pi via Bluetooth. And if you have a digital audio card, you can use that to connect your Pi to the line input of your hi-fi stereo receiver. So you can generate high quality music on your hi-fi. So it's a cool little app for your Pi, and here's how it's done. Before we dive into the configuration settings of our Pi, I'll introduce you to some of the basic concepts that will be used. And by the way, by clicking the link below, you can download all instructions. As I mentioned already, we configured the Pi to use Bluetooth so that we can stream high-quality music from our phone or tablet to the Pi. And for this to work, we need a Bluetooth-enabled phone or tablet and the Pi. By the way, what is Bluetooth actually? Bluetooth is a standardized protocol for sending and receiving data over a wireless link. It operates in the 2.4 GHz band that is also used by Wi-Fi, and in fact, Bluetooth and Wi-Fi use the same chip in a Pi 3. And there's another similarity between what you're probably familiar with in IP networks and Bluetooth, as Bluetooth also uses a 48-bit address on each chip to identify the Bluetooth controller. It's also defined by a user-friendly name, which is the Pi's host name by default. You'll see that we'll rename the Pi from Raspberry Pi to Audio Pi, and that's the name you'll find on your device. Another important concept is represented by the Bluetooth profiles, which are additional protocols on top of the basic underlying connection protocol. They are used for specific use cases, and in our scenario we're using the headset profile. And the headset, by the way, is also the little icon that'll pop up on your phone. Imagine to go through the connection process step by step. Switch Bluetooth off on the phone first. Now we'll activate Bluetooth on the Pi. We must ensure it's configured to have its controller powered on, that it's discoverable and pairable. What does it mean? Well, let's switch Bluetooth back on our phone. What happens is that your phone will run an inquiry to try and discover the Pi. The Pi is listening for the inquiry, will register the device's name and address, and will reply with its own address and its name. The Pi will appear in the phone's available devices tab. You can see that in the red box. Next, we'll enter the pairing process. Pairing allows for devices to automatically recognize each other and connect automatically if they're configured to do so. Pairing usually requires an authentication process to validate a connection. Given the Pi has no user interface, pairing will work automatically. However, we still must make sure that the Pi trusts the paired device. Otherwise, it will disconnect the link. Well, now that pairing is completed, the connection is set up and music can be streamed to the Pi. Here we go. So let's start to build our Bluetooth audio receiver now. And we'll execute two very simple steps. So first thing we're going to do is to give our Pi a meaningful name, and then we will upgrade the system. Let's first SSH into the Pi itself. And changing the Pi's host name is actually very easy through the interactive Raspberry config menu screens. So you just have to type sudo raspberry config and that will take you to the menu. Select the advanced options, the host name, and we're going to change this now from Raspberry Pi to Audio Pi. You can select the arrows and the tab and enter. We've finished now and reboot our system. I will do the system upgrade. Let's SSH back into the Pi. And you will see that the hostname has changed now to Audio Pi. You can see that here. To do the update, you just type sudo apt get update and that will update your system to the latest version of the current release. That will take a little while. I'll just interrupt. Now the update is complete, and let's proceed with the upgrade. That will upgrade your system to the latest Raspbian release. So that is, just change this to upgrade and start. Now, according to your current software level, that might take a long time. Just accept the changes and let this upgrade install. That will also upgrade and install all of your Bluetooth drivers and software that is required for the Bluetooth audio receiver to work. So once your Pi is upgraded and updated, you're good to go. You can check the release that you're running. There's a couple of commands that I can quickly show you very quickly. With uname -a, you will see a different information about your actual kernel release and Linux type, and you can get more information with the command cat etc. and the OS release. And you can see that we're running Jessie and a Raspbian version. So all of our Bluetooth drivers and devices are part of this software release. We will now change the Bluetooth configuration of our Pi. In order for us to do that, we have to type sudo vi/etc/bluetooth/main.conf, where the configuration file for Bluetooth is located. And the first thing that we have to do is to add a line under the general section to make sure that our Pi is a source and a sink for audio media, and therefore we can insert a line that I've previously copied just at the end of the general section here. The next thing that we have to do is to change the default class of our Pi. We want this Pi to behave as a media device, and that will make sure that the little headset icon will pop up on your phone when you discover that Pi or pair with that Pi. So for us to do that, we need to change the class information. Let me just copy this and just insert that information here. The next thing that we have to do is to make sure that our Pi is discoverable, so that other devices will find it if they're switched on and start scanning for other devices. So let's just uncomment this line. We want the Pi to be discoverable forever. And we will do the same for the pairable timeout, because we want our Pi to be able to handshake and authenticate against other devices, because we will need that in order for the Pi to connect later with your phone or tablet. That's all that we have to do. We will now write the results of this file back. We'll use Pulse Audio as the Pi's sound server, to which the audio media will be streamed over the Bluetooth connection and reroute the stream to the DAC sound card. For us to have Pulse Audio work, we first of all have to change the configuration, because we have to add a resample method. For you to do that, you have to type sudo vi/etc/pulse/daemon.conf. And you have to go down to the section where the resample method is specified. You can see This is set to speaks float and it's commented. So we're just going to add an uncommented line here. Let me see if that works. So the resample method is trivial, but I think I have to change the capital R to non-capital. So just let me insert this, and that should be all that we have to do. Simply reboot your Pi now. To configure your digital audio card, you'll have to make some changes to the config.txt file in the boot directory. So just type sudo vi/boot/config.txt and scroll down to the very bottom of this file to the device tree parameters and just uncomment what is relevant to your setup here. So we need to activate the I2S parameter, and we also need to activate the device tree overlay as compatible to a Hi-Fi Berry DAC Plus. In my case, mine is a Pi-Fi DAC 2+0. Make sure that the device tree parameter audio on, which loads the native driver, is uncommented. That's very important as well. And save your changes. We'll now force the audio output to the audio jack of the Pi, and we do that by entering the interactive menu again. Select the advanced options, select audio, force the headphone jack, and finish. Simply reboot your Pi now. At this point we have completed the base configuration of our Pi. Let's SSH back into it. And let's try to set up a connection with our mobile phone now. But first we need to activate Pulse Audio and daemonize it. So we'll do that by typing Pulse Audio and -D to daemonize it. Now the sound server is running. We'll enter the interactive Bluetooth CLI now by typing Bluetooth controller. And you can see the address, the MAC address of the controller here, and the name that's been given, AudioPi. If you type help, you will see all of the available commands that are available to you. The controller is the default controller that is active here, and I can show its attributes. And you can see all of the attributes here. You can see it's called AudioPi, that it's a media device class that we've set in the config file, that it's powered, that it's discoverable, that it's pairable, that's an audio source and sync. So we're ready to go. If you switch on your phone and set it to activate the Bluetooth, you should be able to see this sort of screen here. So if you click on the available devices on the AudioPi, like this on your phone, you will see that the new device appears in the CLI as paired device, and you should see the same phenomenon on your phone screen. It should appear as a paired device. Try to connect your phone now. And what you see is that the connection will be established and immediately released. That is because the phone is not a trusted device. First, we need to trust it. We type trust and we just copy the phone's MAC address. Copy and paste. Once the trust is succeeded, we click again. Let's do it on our phone as well. And now we should be able to connect. It might take a little while. Now we can see that our phone is connected. Something like this should appear. Try to stream some music now. If you're using Wi-Fi, you see that it works, but that the audio quality is bad and that the audio stutters. That's a little bit unfortunate, and it's due to the fact that Wi-Fi and Bluetooth are implemented on the same chip and that there are some driver or hardware problems. Unfortunately, you need to stop the Wi-Fi and you bring your WLAN 0 interface down. So we'll do that now. We need to quit the Bluetooth interface shell and type sudo ifdown WLAN 0 to bring our wireless interface down. If you're accessing through Wi-Fi as I do, you will lose any control that you have on the interface. But given that the Pi runs headless, it doesn't really matter. Let's automate the interactions we've just seen. As our Pi will run headless without any user interaction, we need it to boot to the command line. So in order to do that, we need to call the raspi config again. And we need, I think, to go back into the advanced options. Oh, the boot options, sorry. Choose B1 and we choose B2. Now we're done. Let's reboot now. As we need Pulse Audio to run at startup, and we need it to run exactly once, we will add Pulse Audio to the startup scripts. All startup scripts are located in a directory which is the /etc/init.d directory, and we just create a new file called Pulse Audio in that directory and just copy this line here and paste it over here. This is a shell script. I will copy the code. And paste it. So this little script now will run automatically with all the configuration parameters that are set. Right, let's make this file executable, otherwise our script cannot run at startup. We do that with the change mod command. Changing it to 755 will change the privileges on the file and make it executable. Finally, register the Pulse Audio scripts to run at startup. You do that with the following command: sudo update _rc.tpulseaudio.sh, and we register it with the defaults. that's it. Finally, we're going to automate the Bluetooth interactions that you've just seen before. We're going to create a little script that we call trust_paired.sh. I've prepared that script already, so these are the contents that it should have. So make sure that you copy those into this script. Of course, as this is a shell script, we start with the shebang. We then have to bring down the wireless LAN interface, as that interface with Bluetooth. And what we do then is that we activate the interactive command line through Bluetooth control, and we pipe a number of commands into it, such as power on, agent on, default agent, to make sure that we use the default controller. We make the Pi discoverable and pairable. This should be given by default, but it doesn't harm to reactivate that. Consequently, we are going to activate an endless loop. We're going to list the paired devices, and we're going to extract the MAC address and the name of the devices, and subsequently we're going to extract the MAC address of each device that's paired and trust it. And after that we're going to sleep for 15 seconds and repeat the entire cycle, which means that your device should be trusted at most 15 seconds after you paired. Let's now save this. Let's now make this script executable again. Lastly, you need to add a line to the Pi's bash shell script .bashrc to make sure that the trust paired script is executed every time the Pi is booted. So just type sudo vi.bashrc, go to the end of the script, and add a line /home/pi/trust_paired.sh. I've done that already, so simply save the file, and now everything is ready. Reboot your Pi and see if things work. Best of luck. Bye bye.